This video is on the unit circle. The unit circle has a radius of 1 and is centered at the origin of the coordinate grid. So remember, the origin would be 0, 0. The exact values of cosine theta and sine theta for special angles are listed on the unit circle. Okay, this part's important. The x coordinates are cosine values and the y coordinates are sine values. So the cycles of sine and cosine functions repeat every 360 degrees or 2 pi, which would be radians. So if we're using the actual degrees, well, the units are degrees, but if we're using pi, it would be referred to as radians. So it's the type of measurement, the unit of measurement that you would measure it with. And if you're using a graphing calculator, you can actually switch between degrees and radians. So we're just going to look at the unit circle. Okay, so if I start at 0 degrees, I'm just going to go around the circle. Okay, this would be 30 degrees, 45 degrees, 60 degrees. We're up to, from 0 straight up would be 90 degrees. 120 degrees. So this is always on a unit circle. It will always be the same. So I'm just going through and giving you the measurements of each in degrees. All right, so over here, this line would be 135 degrees. We have 150 degrees. Right, all the way halfway around is 180 degrees. All right, down here, we're down to 210 degrees, 225 degrees, 240 degrees. All right, so if we go 3/4 of the way, we're at 270 degrees, up to 300 degrees, 315 degrees, 330 degrees, and if you go all the way around, you end up at 360 degrees. So the starting point and the ending point will start at 0, end at 360 degrees. So that's in degrees. Our other way of measuring is using radians. So we're going to go through and we're going to re-number using the measurement of radians. So we're going to use pi. When we're at 0 degrees, it would be 0 pi. 30 degrees is pi over 6. 45 degrees, pi over 4. 60 degrees is pi over 3. All the way up at 90 degrees, we are at pi over 2. Okay. 120 degrees is 2 pi over 3. 135 degrees is 3 pi over 4. 150 degrees, 5 pi over 6. Okay, so then when we go halfway, 180 degrees is the same thing as pi. Okay, and then we go down to where we have 210 degrees is 7 pi over 6. 225 degrees is 5 pi over 4. 240 degrees is at 4 pi over 3. Right, then we're 3/4 of the way around. 270 degrees is 3 pi over 2. 300 degrees, we're at 5 pi over 3. 315 degrees is 7 pi over 4. 330 degrees is 11 pi over 6. And when we get all the way around the circle, 360 degrees is the same thing as 2 pi. So as I said above, the cycles of sine and cosine functions repeat every 360 degrees, so all the way around 360 degrees, or 2 pi in radians would be all the way around. Okay, so now we're going to look at the cosine and sine values. So remember I said before, the x coordinates are cosine values, the y coordinates are sine values. So let's start at 0. So over here, I'm going to switch between colors, just if you want to do this too, so you know that one color was in degrees, another color was in radians. Then I'm going to create coordinate pairs, an x coordinate and a y coordinate. I'm going to have all my x coordinates in one color, so I know those are the cosine values, the y coordinates in another color, so those are the sine values. So anytime you have to quickly look at your unit circle, if you're solving a problem, it does make it a little bit easier. All right, so we're going to create this ordered pair. So my first ordered pair, the x coordinate is 1, y coordinate is 0. So remember I said that the radius is 1 unit. So that means the distance from, I said this is 0, 0, the origin out to the side would be 1 unit. So I'm just going to go around to these 4 points because this is the x-axis, y-axis, and we're just going to put those points in to start with. Okay, so when we're straight up, we know that the x-coordinate is 0 anytime we're on the y-axis, and because it would be 1 unit from 0 straight up, the radius, the y-coordinate is 1. All right, over here, okay, this would be -1. And our y value would be 0. All right, our last easy one. Okay, we have an x value of 0, a y value of -1. Okay, so those are, because these lines are our x-axis, our y-axis, and we know the radius is 1. So those are the easy ones. Now we're going to look at the other ones and determine the x and y coordinates. So let's start, I'm going to just talk about degrees. Let's start at 360 degrees. So x is square root of 3 over 2. The y coordinate is 1/2. At 45 degrees, we have an x coordinate of square root of 2 over 2 and a y coordinate of square root of 2 over 2. So these are exact values. You see, I don't give you decimals, I don't round it. You want to make sure when you're using the unit circle, anytime you have these degrees or radians, you're using the exact value. All right, so up at 60 degrees, x coordinate is 1/2. The y coordinate is square root of 3 over 2. All right, so we already went straight up at 0, 1. Let's go over to 120 degrees. Our x coordinate is -1/2. Y coordinate is square root of 3 over 2. right at 135 degrees, our x-coordinate is negative square root of 2 over 2, and our y-coordinate is positive square root of 2 over 2. Okay, now let's go down to 150 degrees. The x-coordinate is negative square root of 3 over 2. Y-coordinate is 1/2. So hopefully you're able to see a correlation between the two sides, because these would be at the same value up here of y, which is 1/2, and they would also be at the same x value, but one would be positive, one would be negative. So it would be the same distance out to this point, because this is where it would be on the x-axis. It does create a right triangle. You can see, same thing up here. We would be creating a right triangle, so same distance out, just one's positive, one's negative, and the y value would be the same. So let's keep going, see if you can figure out the pattern. One thing I want you to pay attention, if we're talking about the coordinate grid, so up here, you know the x-coordinate's positive, y-coordinate's also positive in this coordinate grid, or in this quadrant, sorry. In this quadrant, our x-coordinate's negative, which yes it is, y-coordinate's positive, which we did see that that works. Okay, down here, both x and y are negative. So let's look at this. You might be able to figure out what it is already. If you want to work ahead and then come back and double check your work based upon what we did on the top, go ahead and do that. So at 210 degrees, x is negative square root of 3 over 2. The y-coordinate is negative 1/2. At 225 degrees, we have an x-coordinate negative square root of 2 over 2. My y-coordinate is also negative square root of 2 over 2. All right, down to 240 degrees. We have an x-coordinate of negative 1/2, y-coordinate of negative square root of 3 over 2. Okay, I can skip all the way down because I already did that at 270 degrees. Skip over to 300 degrees. We get an x-coordinate of 1/2, y-coordinate of negative square root of 3 over 2, up to 315 degrees. The x-coordinate is square root of 2 over 2, y-coordinate negative square root of 2 over 2, and our last one here at 330 degrees, the x-coordinate is square root of 3 over 2, and the y-coordinate is negative 1/2. All right, so hopefully you were able to see how all the quadrants related to each other. And you can use the unit circle to help you figure out exact values for sine and cosine, looking at the x and y coordinates. And we have the degrees and the radians here.